Hi and welcome back to another LeetCode video. I'm currently on a run solving LeetCode easy problems to practice the interview process. And I'm looking at problems that I haven't seen before and haven't tried before. But let's see how I fare with this one. So this is LeetCode 3477, fruits into basket number 2. And we're given two arrays of integers, fruits and baskets, each of length n, where fruits at I represents the quantity of the ith type of fruit, and baskets j represents the capacity of the jth basket. From left to right, place the fruits according to these rules. Each fruit type must be placed into the leftmost available basket, with the capacity greater than or equal to the quantity of that fruit type. Each basket can only hold one type of fruit. If a fruit type cannot be placed in any basket, it remains unplaced. Return the number of fruit types that remain unplaced after all possible allocations are made. Cool. And the constraints are, well, we have n fruits and n baskets. And well, we have at least one fruit in one basket. And then the capacity and the count of fruits is at least 1 and has some limit. Right. So I'm thinking right now we just need a linear path through the array and keep track of fruits that we place and cannot place. Yeah, that's probably what we have to do. Well, yeah, so let's look at an example here. So fruits is, oh, we have 4, 2, and 5 fruits of type 0, 1, and 2. And our basket has a capacity of 3, 5, and 4. Right. Okay, so, right. Fruit 0 is 4. It can be placed in basket number 1, right? 4 fits into basket number 1. Fruits 2 can be placed in basket number 3. And fruits 2, 5 cannot be placed in basket number 4. Since some fruit type remains unplaced, we return 1. Okay, but I would have chosen it in a different order, but we're not allowed to do that. So each fruit type must be placed in the leftmost available basket. Right. Cool. If a fruit type cannot be placed in any basket, it remains unplaced. So my question is now, if I cannot place a fruit type in any basket, do I just run, well, what do I do? Do I not use the remaining baskets because, okay. Or do I skip over that if I cannot place it? Let's look at the second example. So fruits is 3, 6, and 1. That's not the counts. I can place 3 and 6. I cannot place 6 and 4, but I can place 6 and 7. Yeah, so that's what actually happened. So we cannot place that back, so I have to place it into the next one. Interesting. And then we can place fruits in basket 1. So it seems like we're looping around. Okay, interesting. I don't know if I have more questions now or not. So we have to abide by the order too. The fruit must be placed in the leftmost available basket, right? Right, so we probably have to do the looping around. And if we have to do that, that's going to be a long time to do that. So that will be probably an n squared, right? We have to iterate over all of the remaining fruits just to find one to place them or something. That's, well, I mean, we could implement that approach. Maybe there's a simpler one as well. We cannot sort the baskets. That's also true. And we cannot sort the fruits, right? Because we have to, we have to pick the next fruit that we can fit into the basket. So I guess what we can do is we can just implement this very in a naive way, where we loop over all of the fruits, and then in an inner loop, we loop over all of the free baskets. Once we place a fruit, No, wait a second. If we cannot place a fruit, it remains unplaced and we cannot place it later. However, in this example, we try to fit the fruit into the basket, doesn't fit, so we pick the next one. All right, so I'm thinking we need, well, O of n squared. That's my preliminary runtime analysis. N by n time. And what else do we need? Do we need any space? I don't think we need any space for. I don't think we need any space. So yeah, so outer loop will be 4. Will be over all of the fruits. Well, and we will loop over all of the baskets inside. So what we'll do is if, well, and we have to keep track of whether we could place it on, right? So if the fruit is placed or not, we need to return variable as well. And that's just the number of unplaced fruits. And if not was placed, well, plus equal 1. Now when we loop over the baskets, if baskets at position j is larger or equal than fruit, that is at, I guess count is a bit. Count is fruits at position. And I guess we could just iterate with fruits. Do that. Now what we will do is, well, if that is larger than count, if the capacity of the basket is larger or equal than count, then we can place it. Was placed. And well, and we have to, well, we cannot reuse the basket for anything else, right? Because every basket can only contain one type of fruit. So we just set this to 0 and we break out of the inner loop. Actually, we can change this now to I since the okay, cool. So that's what we do. Outer loop is O of n, inner loop is O of m. Well, wait a second. Well, they're both the same, so it's n squared, right? I think that would be kind of a brute force approach. And let's see if that works even. And passes the test case tool, and let's see what happens when we submit this. Okay, so that also works. Now the question is if whether we can come up with a solution that is a little bit more effective here. Because, well, it's kind of difficult, right? If we, well, we could keep track of, I guess, you know, I don't think we can make substantial efficiency improvements here. Even if we reduced the number of baskets in every step, it will still be O of n squared. And we need to maintain the order of the baskets, so we can't just pick any basket where it fits in, right? Yeah, I think I'll leave it at that. That's going to be my solution for this problem.